Hi, welcome to the Olympiad geometry. Let's continue our study on incenters. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Thank you. So, here is a problem. Let's just draw the figure with reading the problem. PQ are points on edge BC AB in triangle ABC. This is triangle ABC. AB plus BR equals to AC plus CR. So we have AB here, we have AC here. It's better that we define the sizing of the edge, right? So let's assume that let's assume that BC is larger than AB and larger than AC based on our figure. That's our assumption. It won't change anything, but it's with this assumption that we would have the polarity of the when we derive the equation, right? So let's just do this assumption here. It won't change the result. So AB plus BR equals to AC plus CR, which means that AB is larger than AC, right? So if this is a midpoint of BC, based on we know here the M is a midpoint of BC. That means R point is on the left side of the M, right? So let's assume that R is here. We have AB plus BR equals to AC plus CR. And we have CB plus BQ equals to AC plus AQ, which means if we assume the midpoint here as N, because BC is larger than AC, right? So that point, the Q, should be on the bottom side of the point N. Let's assume it's here. That is Q. Now, AR intersects CQ on J. So let's connect to AR. Let's connect to CQ. Right, AR means CQ on J. This point is J. And I is the incenter of triangle ABC. So that's roughly say the angle bisector line, and this would be the angle bisector line. So it meets here, right? That is I. And we want to prove that AJ is in parallel with MI, and AJ equals to twice of MI. So if you just look at the problem, it's kind of a difficult problem because we have no idea how to use this. AB plus BR equals to AC plus CR. A natural thought would be that, oh, should I extend the AB to a point that lets, for example, extend the AB to D and let BD equals to DR. So we know that AD here, and extend AC. Then we got an isosceles triangle. But no, just think about this problem here, that we want to prove that AJ is in parallel with IM, right? And we already know that if we connect AI and extend it to BC on point K, right? So we know the ratio of AI to IK. We learned this before, right? And assume that the length of AB is C, the length of BC is A, the length of AC is B. So AI to IK equals to B plus C to A. That's a property of the incenter. We learned it before. So we want to prove that IM and AJ are in parallel. And we already know the ratio of AI to IK. So we just need to find the ratio of RM to MK, right? And then we prove that they are equal to the AI to IK. Then we prove that RM is in parallel with AG. And can we find the length of RM? Yes, we can, right? Because we know that AB plus BR equals to AC plus CR. So we know the length, we can calculate the length of BR and CR. And we know that M is a midpoint of BC. So we can calculate the distance of RM. And because AK is an angle bisector of angle BAC, so we know that the ratio of BK to KC equals to AB to AC, which means that we can calculate the length of BK, which means we know the length of MK. Right? We know the length of RM and we know the length of MK. We can calculate the ratio and we compare with AI to IK. Right? So that's clear. The path of the proof, right? So let's do the calculation. First, we know that AB plus BR, which is C plus BR, equals to AC plus CR, which is B plus CR. And we know that BR plus CR equals to A, so BR plus CR equals to A, right? Based on this, we use this one minus this. So we got CR minus C equals to A minus B minus CR, which means 2CR equals to A minus B plus C, right? And based on our assumptions that BC is larger than AB and larger than AC, which means A is larger than C and larger than B, right? The B is the smallest part, so that means CR equals to half of A minus C minus B, right? And we can calculate that BR equals to half of A plus C minus B, right? Okay, now we know the length of BR, we know the length of CR, and M is a midpoint, so BM equals to MC equals to half of A, which means RM equals to half of A minus BR, which is half of A plus C minus B, so it equals to wait, let me see. Oh, this is wrong, right? This is minus, this should be plus, right? And here should be minus. This should be minus. Sorry about that. So that should be half of C minus B divided by 2, right? Here I did a mistake here. So A should plus C minus B, right? That's a CR, and here is a BR. And then we calculate for the RM. We got this. So for BK, we know that BK to KC equals to AB to AC equals to C to B, which means BK equals to AC to B plus C, and CK equals to AB to B plus C, right? Which means that MK equals to BK minus BM equals to AC to B plus C minus BM is half of A, right? That is 2AC divided by 2 of B plus C minus A times B plus C, so it equals to AC minus AB divided by 2 of B plus C, right? So it equals to A times C minus B, 2 of B plus C. That is BK. Okay, now RM to, that is MK. RM to MK equals to, where is RM? RM is here, so C minus B divided by 2 and 2. mk, right? mk is ac minus b to b plus c, which equals 2. So you can see that, yeah, maybe I reform this one, c minus b divided by 2 and ac minus b divided by 2 of b plus c. So you can see these two are cancelled, and b minus c minus b are cancelled, and this b plus c flip to the denominator, which is b plus c divided by a, right? And this one equals to this one, ai to ik, right? So we got aj is in parallel with im. Okay, aj is in parallel with im. And similarly, because we know that BC, we just use this one, right? We just use this problem set. We have this left, right? So what about point Q? We find the midpoint of AB. We call it N, and we just prove that AJ in parallel with IM, right? So for the IN, we can just use the same way to prove that CJ is in parallel with IN, right? So I'll just write it. CJ is in parallel with IN. And because M is a midpoint of BC, N is midpoint of AB, so NM is in parallel with AC, and NM equals to half of AC, right? Now let's see. See this one? IN is in parallel with CQ, and NM is in parallel. NM in parallel with AC, which means this angle, the angle INM, equals to angle ACQ, or angle ACJ, right? And because IM is in parallel with AJ, NM is in parallel with AC, so we know that angle IMN equals to angle CAJ, right? So we know that triangle ACJ is similar to triangle MNI, which means IM to AJ equals to MN to AC equals to 1 to 2, right? So we just prove that AJ is twice of MI. Okay, I think this is a very interesting problem because we find a good way to use problem set, right? It's not that straightforward to think of how to use this problem set as a very first, but once you check on these points, and you can realize that we can actually calculate all of these segments, and then we find the ratio, everything becomes straightforward. Okay, I hope you like this video. See you in next one. Thank you.